As we sit here looking at James Watt waiting for his tea kettle to boil, was it Papin or Newcomen who invented the first steam kettle? How steamed was James Watt to invent his own engine? How many students can boring machines produce as opposed to boring professors? These and other questions will be answered right after this. I am Professor Jerome Arkenberg, and I've been teaching a wide variety of history courses at colleges across this country for the past 30 years. In this video, I'm going to tell you about the difference between undershot and overshot water wheels and how that impacted early industry, why steam engines were developed and how many watts it took, and how steam impacted the Industrial Revolution. At the end, I'll have the wrap-up quote on this video, so make sure to stick around for that. But first, make sure to click like, share, and especially subscribe and that little bell thingy so I can continue to bring you more great videos just like this one. The Romans used water wheels for power, but these were mostly undershot. The ones that you see here. In other words, either the wheel goes only as fast as the river flows, which is what you see here, or the water goes this way, and again, however fast the water going down goes. So it turns slowly with the flow of the current, but it's useless on lakes and in marshes. In the Middle Ages, more efficient overshot wheels were devised. In other words, like here, the water, instead of flowing this way, it flows this way. And the idea is you take water from an earlier part of the stream and you put it into a separate channel, and then increasingly you narrow the channel until it gets to the water wheel itself. But at that point, since it's being narrowed, the water is really moving fast, and hence it will really move that water wheel fast, kind of like this one. Well, this one seems to be on hyperspeed, but you got the idea. So these more efficient overshot wheels were devised in the High Middle Ages, which not only were used to grind grain, but also to crush ore, pull cloth, pump water, and work the bellows of a blast furnace. In the 18th century, these overshot wheels powered the first factories, like this one. So again, all these machines being powered by this one water wheel, kind of like these as well. The trouble is, these had to be confined to the hills, where water flow was fastest, but transport of finished goods were difficult and labor was not plentiful. This was solved by the invention of the steam engine, which began with rising demand for iron in the 17th century, leading to the opening of new mines and exploitation of older ones. But deeper and deeper you had to go below groundwater, causing flooding problems, as you see here. So what to do? Well, in ancient and medieval times, we used water wheel powered pumps. So remember, the wheels were only going as fast as the water flow because, of course, these were undershot wheels. So these were a poor way to keep out the water in these mines, though it's better than nothing, which spurred the use of the first steam engines to pump out the water. The first modern steam engine, by the Frenchman Denis Papin, seen here, was built to pump out water in deep mines and replace the more inefficient water wheel pumps. But it was so large and inefficient that few were built. The first practical steam engine was patented in 1689 in England by Thomas Savery. And it all worked well, as you see here. So it superheat the water, turn into steam, change a little bit of spritz. The trouble was the boilers tended to explode, which, as you might imagine, limited its adoption. In 1712, Thomas Newcomen, picture seen here, built a more efficient machine that forced steam from a boiler, there we are, into this cylinder containing a piston connected by a rocking T-beam, that's this thing up here, to a pump. That's the pump. So after the steam forced the piston to the top of the cylinder, a jet of cold water inside the cylinder condensed the steam, creating a vacuum, causing the loss of pressure to quickly depress the piston and actuate the pump. But his engine was cumbersome and expensive, requiring its own building. Still, it was effective, better than Papin's engine, better than a water wheel pump, and thus it was widespread in the 18th century, primarily used to pump out deep mines. In 1769, James Watt, who was born in 1736 and dies in 1819, who was a mere lab tech at Glasgow University, improved a Newcomen engine by adding a separate condenser, eliminating the need for alternate heating and cooling of the cylinder. But lack of proper machine tools to properly bore cylinders to create a better vacuum seal limited its use. And that was the problem. Between this piston and the cylinder, you need a fairly tight seal. Kind of like in a car, though that's what the oil is for, also to keep it from overheating. But this was kind of the problem. In 1774, in partnership with a local investor, Matthew Bolton, Watt used a man by the name of John Wilkinson, who had invented a new boring machine to produce cylinders to proper tolerance. And then a key item, he added a governor. And the governor is this thing, these two metal balls, which you see here. These two metal balls, as you see here. The idea is it would regulate speed and gears. So when the machine started to go too fast, for example, the things would simply rise up and as it sit at the top, it would close off the valve automatically and then everything would smooth back down so it wouldn't explode. Here's the same cylinder, but of course, put on its side. He then added gears and belts, which has enabled you to convert reciprocating to rotary motion, allowing the steam engine to, via the use of the belt, power all sorts of other machines, and allowing Watt and Bolton to make a small fortune selling more efficient and powerful engines small enough to not need their own buildings. And by the way, I should say they didn't actually sell the machines. They gave people a license to use them. much like software today. So if you didn't pay the license, they would simply come and take your machine away. So harnessed to shafts and belt drives, Watt's engine was adopted for manufacturers of all kinds. Now, factories could be built anywhere that coal could be delivered. So you don't have to build them anymore up in the hills where there are very few people, and transporting goods is difficult because it's uphill, obviously, and roads are not good. You can do canals and railroads, but even better, put it down in the lowlands or even on the coastline where there are lots of people and lots of labor available. And it's easy to ship goods in and to ship goods out. So factories can now be built anywhere that coal could be delivered and burned for steam. This cut down on the cost of labor and transport, lowering prices and making material goods available to all. In other words, all of these machines, by way of this belt and this central rod or shaft, they all connect to the one steam engine with its own belt powering everything. And here's the wrap-up quote. Steam engines furnish the means not only of their support, but of their multiplication. They create a vast demand for fuel, and while they lend their powerful arms to drain the pits and to raise the coals, they call into employment multitudes of miners, engineers, shipbuilders, and sailors, and cause the construction of canals and railways. Steam engines, moreover, by the cheapness and steadiness of their action, fabricate cheap goods and procure in their exchange a liberal supply of the necessaries and comforts of life produced in foreign lands. They make it possible to fabricate some articles which otherwise could not be fabricated at all. They enable an operator to turn out a greater quantity of work than he could before. And they effect a substitution of labor comparatively unskilled for that which is more skilled. Andrew Urey, 1835. So let me know what you think of this quote in the comments section below. Also, what you liked about this video, and what other historical topics or subjects you'd like to see in future videos. Be sure to click like, share, and especially subscribe, as it will help me bring you more great videos just like this one, and click on that little bell thingy so you'll know when the next History Waits for No One video is posted. If you want to know more, there are recommended studies on this topic in the description below, along with other ways to connect with me. Thanks for watching, and I'll see you in the past.